Welcome to Coffee Break, the live stream series brought to you by Microchip Technology, where our mission is to educate, entertain, and empower you to innovate in your designs. I'm your host, Dana Curtis, and you are watching Season 14 of Coffee Break. As always, we're here to dive into the fascinating world of embedded control technologies, integrated circuits, and all things smart, connected, and secure. And about the time it takes to enjoy a fresh cup of coffee. For those of you joining us for the first time, welcome. Coffee Break is a live broadcast, and we encourage audience participation. Before I introduce our special guest, let's take it over to Aliyah Fahout for some housekeeping items. Aliyah, what do you got for us?
Thanks, Dana, and hi, everyone. Thank you for joining us today. We are currently live on YouTube, Facebook, and LinkedIn. We invite you to participate in this episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after this broadcast. If you're with us on YouTube, make sure to subscribe to our channel and click the bell so you know when we're live and when our next episode is. If you're with us on LinkedIn, subscribe to the event so you can get all the information related to this episode. Back to you, Dana.
Thanks, Aliyah. Today we have a very special guest joining us. Hakeem Sharif is an applications engineer at Microchip Technology. Welcome, Hakeem. You are joining us today to talk about AI ML development for Microchip microprocessors with Edge Impulse. So, we've got our coffee ready. Let's start with the obvious question. Why do we need AI ML at the edge?
Hello, Dana. Many thanks for the invitation. Well, why do we need AI/ML at the edge? Basically, most of you know that today AI/ML is a very powerful technology, and we can benefit of this technology for embedded devices. And why do we want to embed AI/ML? There are different advantages, but the main advantages are related to the latency, the privacy, and the security of the data.
Latency, okay. So we're talking a lot about artificial intelligence and machine learning, but can you remind us of what those terms mean, just for anybody that's been under a rock for the last few years?
Yes, of course. Good question. So what is AI, what is ML, what is DL deep learning? So first of all, I'm going to start by defining artificial intelligence. So basically, the artificial intelligence is a word that represents the group of techniques which enables and makes it possible to mimic human behavior. Artificial intelligence is not a new topic. Artificial intelligence has started since the 50s, as you can see on the image here. But recently it was made possible by new discoveries in mathematics. And let's talk now about machine learning. So machine learning, this is a subset of artificial intelligence. And this is basically a subset of techniques that makes possible for machine to train, to learn with experience. This is this whole training thing. And regarding deep learning, what is deep learning? The way I like to define it and the way the definition I'm gonna share with you is that this is basically this whole neural processing thing, this whole neural network thing. Basically, with deep learning, it is possible to kind of emulate or represent mathematically the neural networks. This is thanks to these new evolutions that today we have the powerful AI/ML algorithm that we know.
Right, so deep learning replicates neural networks to how animals and how humans think, right? Is that fair to say?
Exactly, yes.
Okay,
exactly.
So I think it's also fair to say that AI is a very powerful technology. Would it be correct to assume that it needs to run on powerful servers equipped with dedicated GPUs?
Well, not in all the cases. It is possible today to run AI/ML at the edge on a wide range of different chips and different products. So basically, here at Microchip, we cover a wide range of products from 8-bit microcontrollers up to FPGAs, PolarFire, and it includes also 32-bit microprocessors. But one thing that I would like to highlight and that it is important to understand is that here it is question of running a machine learning model, which means doing the inference of the machine learning model. It is not question of training, because training a machine learning model, in most of the cases, we will need powerful GPUs, powerful servers, etc., etc. In most of the cases. Not all the time, but in most of the cases. And here it is question of running the models. And yes, it is possible to run the model at the edge. And here I'm going to talk about a 32-bit microprocessor, the SEME A7G54. This is typically this a microprocessor that we recommend for doing artificial intelligence. So this is a Cortex A7 single core MPU. It can run up to 1 gigahertz, and it supports 533 megahertz of DDR3. Sorry. One thing also that I would like to mention is that this product has been made also to be used in the kind of HMI human-machine interface applications. This is why there is a MIPI CSI2 camera interface. There is also an audio subsystem. This product, this microprocessor, also embeds hardware security features and is qualified for some automotive applications because it is qualified ACQ 100. And one thing that some of you might have noticed in the audience is that this product is a single core product and does not have any neural processing units. And yes, it is still possible to run machine learning on this kind of tiny chips.
Right, so it's that basic difference between running the model and training the model, right? This being a new application of this technology for Microchip, what do you recommend our viewers to get started? Where would they get started with Microchip 32-bit MPUs?
Well, excellent question, Dana. Thanks once again. So basically, I would recommend our viewers to get started by using the tool from our partner, EdgeImpulse. So basically, when you want to create a machine learning application, and the first step is after defining the requirements, of course, of the application, the first step is to acquire data. Then after doing the data acquisition, you need to do data processing and labeling. That includes data cleaning, for example, etc. Once the data is ready, you typically need to train the model. You need to train the model and to optimize the model. Once the model is trained, you need to evaluate it and maybe retrain it depending on the evaluation. Then there's a need for deploying the model to embedded targets. Then we need, of course, to run the model on the targets thanks to an inference engine. And at the end, ultimately, you might want to do some over-the-air updates. Okay. All these steps that are covered by EdgeImpulse, all these steps require a lot of expertise. And we are aware that you might not be an expert in all these steps. This is why, thanks to EdgeImpulse, it is possible today to do all these steps seamlessly and easily. So EdgeImpulse, what is this? So EdgeImpulse, our partner, this is a company based in the US that have been funded by people based in Europe. And this company has developed a whole ecosystem that makes it possible to train and deploy AI/ML models easily. First of all, their ecosystem includes the EdgeImpulse Studio. This is an online platform with a very optimized graphics user interface. This online platform is very easy to use. You can trust me, I have used it, and is very easy to use both for beginners and AI/ML experts. When I mean beginner, I mean someone that is, for example, a software engineer with no experience in AI/ML can easily use it. And their whole ecosystem includes also some Linux packages, because today we use the EdgeImpulse toolset under a Linux environment for our microprocessor. So it includes also Linux packages to help acquiring data from a set of targets that can be already deployed to the field, and then, of course, deploy the model and run these models on the targets.
Sounds like a pretty robust system. With that, let's get over to Aaliyah to see what kinds of questions we're getting from the interwebs. Aaliyah, what do we got?
All right, so we got our first question from Jacob from LinkedIn. He would like to know, can you elaborate more on the different types of AI/ML applications you are targeting?
Yes, thanks, Elia, for this question. So today we are targeting three main types of applications. The first one that I would like to mention, this is the computer vision applications. So we target computer vision applications, more specifically image classification and object detection types of applications, with one catch. This is that we target it for the edge, so without any video live streaming, and we can reach a pretty interesting frame rate depending on the model architecture that we use, and thanks to the Edge Impulse inference engine. We target, in a second time, we target also audio applications, typically audio keyword spotting, spoken commands, this kind of applications. And the third one, this is what I like to call sensor-based applications. So it includes a wide range of applications based on sensors, for example, the predictive maintenance, some signal monitoring, etc., etc.
Great, thank you. Your next question is from Leanne from YouTube. On your MPU, do you support object detection ML architectures like ResNet and YOLOv 7?
So thanks for this interesting question. So today, the YOLO, the typical object detection architectures like YOLO v7, ResNet, etc., are what we considered big architectures, architectures that are too big to run on our target. For these specific architectures, you would need to have a dedicated hardware like a neural processing unit or a multi-core product, etc. Today, what we support and what we recommend, this is an in-house architecture made by Edge Impulse. This is the FOMO architecture. So what is FOMO? FOMO stands for faster objects, more objects. This is a machine learning architecture that is based on a MobileNet v2 backbone. So MobileNet is much more suitable for embedded applications, and here it is based on MobileNet v2. But there has been some changes that have been made in the latest layers of the models to basically makes it possible to run on really tiny targets. This is a very interesting model, but there is a catch, so it always depends on the application, because this model only outputs centroids on the object. So basically, let's say, for example, you want to detect a face in an application. Basically, with ResNet or YOLO model, you will get at the end of the model, at the output, a bounding box that will show you exactly where the face is located and the dimensions of the face. While with a FOMO model, you will only get a centroid, so a point at the middle of the object. But this is a way to make these kind of applications possible for our microprocessors.
Great, thank you, Hakeem. Your next question is from Gurpreet on YouTube. Will object detection, object count, object recognition be possible with MCUs from cameras?
So I tend to think that yes, because we have proof that the FOMO architecture works also on, I think it was Cortex M4 or Cortex M7 MCUs. So this will definitely be possible, yes.
Great, thank you. Here is another YouTube question for you. I am planning to start an ML project in my company. Do you have any advice regarding the metrics that I should use to establish the requirements?
So that's a very good question. And this is true that we tend to see amongst our customers that sometimes it is difficult to define the requirements of a machine learning application. So I would say, first of all, you would need to define the global type of application. Do you want to do object classification or image classification, object detection, sensor processing? Once this is defined, you need to define the types of labels. I'm making my explanation simple, but the types of labels that your model will have to support. What will it do basically? And then in terms of metrics, I would say that the most important metrics are, first of all, the accuracy that you want to reach with your model. So this is important to study what accuracy you want to reach, and saying I would like 95% accuracy for me is not a good way of expressing the requirements, because you need to define which accuracy. Is it MAP, mean average precision? Is it the F1 score? Is it any other accuracy? Then you need also to define the expected latency. This is important. The expected latency, I mean the inference time of the model, your target inference time. And this is important to define it consistently with your application. We have seen people for some applications wanted to do, let's say, for example, being able to process 30 images per second. And when we discuss with these people, we understand that in reality, the requirements are for 5 images per second. So this is important to define the inference time correctly. And then I would say the RAM usage and the ROM usage. But for the microprocessors, I would say that usually we see that the use of the RAM of the DDR is not a problem because we can support with our system in packages up to 4 gigabits of DDR.
Great, thank you. Here is another YouTube question. How to train models and deploy in MCUs?
How to train models and deploy for MCUs? Well, basically, today with the Edge Impulse toolset, it is possible when you go in the studio to select basically a target. So if you want to use a Microchip MCU, you can basically, so today we have no Microchip MCU officially supported in the studio, but you can define a custom target. So basically in the custom target, what you're going to do, you're going to choose the, first of all, the type of core, Cortex M4, Cortex M7, or anything else. And then you will define your application budget. So the inference time that you can have, the RAM usage and the ROM usage. This is what you're going to do. That's the first step. Then when you will train your model using the different tools, these settings will be taken into account. And then in order to deploy it, you can basically, thanks to the Edge Impulse Studio, you can get the project as a C++ project, a C++ API where everything is self-contained, and then you can make sure to integrate it in a MPLAB Harmony project where you will have to integrate this package in order to cross-compile it and to basically build your whole application. So you will need also to create a Harmony, MPLAB Harmony project. And so that one this one was for the Edge Impulse toolset, but it is also possible to use our in-house solution that is more suited for bare metal applications as well. If you want to do sensor processing, signal processing, it is not possible to do computer vision with this one. So for computer vision, you typically want to use Edge Impulse, but for sensor processing application, it is also possible to use our tool, the AIML Development Suite. Thanks for this question.
Of course, thank you. Let's do maybe 1 or 2 more questions. This one is from YouTube. Any demos for AI/ML on MPLAB X?
So, yes, I know that there are demos, AIML demos on MPLAB X. You can find these demos in 2 different locations. What I would recommend you, and maybe the most simple one, is to go on MPLAB Discover. So MPLAB Discover, this is a website that we have and that we maintain that contains all our projects, and basically you can sort that to display only the AIML projects. The other possibility is to go on the GitHub repository of the MPLAB Harmony framework, and then typically go to the, I think it's TF-Lite Micro Apps repository where you can find also the examples.
Great, thank you, Hakeem. Those are all the questions I have for you today. So for the audience, if you have additional questions or comments, please email us at livestream@microchip.com after this broadcast. And don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Dana.
Thanks, Aaliyah. Well, that concludes our coffee break for today. Special thank you to Hakeem for sharing his knowledge and passion with us today. It's conversations like these that remind us of the endless possibilities empowering your innovation in the world of embedded control and processing. If today's topic has sparked your interest and you'd like to learn more, I encourage you to visit our website, www.microchip.com, where you can dive deeper into the world of microchip technology. And if you'd like more coffee break, head over to microchip.com/coffee break and click on the subscribe button to get updates for all things coffee break. You can also see upcoming episodes for season 14. And of course, be sure to join us next time on Coffee Break as we explore Microchip's academic programs. We'll have a very special guest for that conversation. That episode will live stream on Wednesday, November 20th. Until then, stay curious, stay creative, stay caffeinated.